So 4.3 talks about arc length and circular motion. So it says in geometry, we found if given a central angle and the length of the radius, we could set up a proportion to find the length of an arc in a circle. The arc length is a fraction of the total circumference, and the central angle is a fraction of the full revolution. So the arc length formula says, likewise from geometry, we know that the ratio of the measures of the angles equal to the ratio of the corresponding lengths of the arc subtended by these angles. That is, that theta over theta 1 is equal to s over s1, where s is our arc length. Alright, if we let theta 1 be 1 radian, then s1 is equal to the radius. And from our previous definition of a radian, from here we can find the formula for the arc length. And we looked at this the other day in our notes. They gave it to us, but we didn't actually use it. So the arc length formula is that your arc length s is equal to your radius r times your theta. Where theta has to be in radians, it's never, ever, 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 ever in degrees. So example 1, it says given a central angle of 60 degrees and a radius of 8 centimeters, find the length of the intercepted arc. Alright, so we've got a radius of 8 centimeters. And we've got a central angle of 60 degrees. So that means this angle here is 60 degrees. And so we are after this arc length right there. So we know that our theta is 60 degrees, and we know that our radius is 8 centimeters. And so we know that our arc length is equal to r times theta, but theta has to be in radians. So I'm going to have to go convert this. So remember to convert. We just multiply it times pi over 180. And so we have 60 pi over 180, and we're just going to reduce our numbers here. So 60 over 180 is 1/3, so we get pi over 3. So when we go to plug this in now, our arc length is equal to 8 times pi over 3. And so we multiply them, we'll get s is equal to 8 pi over 3, and it's a length, so it's going to be in centimeters. Or we could go ahead and put pi on our calculator, so 8 times pi divided by 3 is approximately 8.377 centimeters. Example 2 says, if a 100-degree arc of a circle has a length of 9 inches, so the arc has a length of 9 inches, to the nearest inch, what is the radius of the circle? So now they gave us our angle, which is the 100 degrees, which we know we're going to convert into radians. And so that gives us 5 pi over 9. And we also know that our arc length is 9 inches. And so we're trying to solve for the radius. So we could look at it like this. Let's see. We don't know the radius, but we know our angle is 100 degrees. So it's going to have to be a little obtuse angle here. All right, and our arc length here is 9. And so we're looking for this radius here. All right, so I can use the same formula. The arc length is equal to the radius times theta. Plug in what we know. Our arc length was 9 equals our radius, we don't know, times theta, which is 5 pi over 9. And then we can solve this. I'm just going to multiply by 9 to get rid of that fraction. And so 81 is equal to r times 5 pi. Divided by the 5 pi. And so we found that our radius is equal to 81 over 5 pi, and it was in inches. Or we could put 81 divided by the 5 pi in our calculator, and it should give us approximately 5.156 inches. So either one of those would be correct. And then example 3, it says find the angle in radians, then convert it to the nearest degree. And so they gave us the picture this time, and so we can see that 5 is our radius, and our arc length is 8. So arc length is 8, radius is 5, and we're looking for theta, and we want it in degrees and radians. So we're going to use our formula. S is equal to r times theta. S was 8 equals 5 times theta divided by the 5. And so we get that theta is equal to 8 over 5. And this doesn't have it's from the problem. And remember, in the problem, the degree is always in radians. So we don't really have a label for radians. But just so we don't get confused later, I'm going to write radians here. Okay, so there's my degree in radians. But it also wanted it in degrees. So remember, if you're going to convert to degrees, you take your radian measure times 180 over pi. And so this would give us, I didn't write it down what I'd get exactly, but I went ahead and just put it in my calculator, and I got 91.673 degrees. And so there's our theta, our angle in degrees. Make sure you put your degree symbol on there. All right, so circular motion, linear velocity or speed. It says, have you ever thought about math while out for a bicycle ride? Probably not. You know how to find your average speed by calculating distance traveled divided by time from long ago. Remember that rate is equal to distance divided by time, or r is equal to d divided by t. In trig, we will call this linear speed or velocity, and we name our variables using v for velocity rate and s for the arc length for distance. All right, so they told us here then our linear velocity formula, v is equal to the change in s over the change in t, or the change in s is equal to velocity times the change in t. So let's look at example 4. It says, if you travel in a car at 65 miles per hour, how far did you go in 10 seconds? All right. So we're looking for how far, so we're after the distance, the arc length there. We're after s, and so we know then that s is equal to v times t from above in our formula. Okay, we don't have to worry about the change in part. Ooh, that's really big. Let me write it smaller. All right, now the only difference I see is here it says 10 seconds, and this says miles per hour. So we're going to have to do some dimensional analysis here to change that, okay? So miles per hour, that is the rate, so that's our velocity. So I'm going to come over here on the side, and I'm going to change that. So if our velocity is equal to 65 miles per 1 hour, we need to be able to change that down to seconds. So remember, we're going to multiply that. 1 hour is what, 60 minutes? And so that makes the hour go away, but now I'm in minutes, and I need seconds. And so we know that 1 minute is equal to 60 seconds. So when we work this out, we get 65 divided by 60 times 60, and it comes out to be 0.01805, and it's in miles per second. All right, so now when I go to find my, how far did I go, my distance, my arc length here, I know s is equal to 0.1805 miles per second times the time, which is the 10 seconds. And so my seconds will cancel, and 0.1805 times 10, I'm sorry, I wrote that wrong. There should be a 0 there. Did I do that on the other one? I did. I just miscopied it there. So when I multiply that times 10, that's where my 0.1805 miles is our answer. Sorry, I hit the thing there. All right, angular velocity or speed. It says now look at another type of velocity while we ride our bicycle. Think about how fast the wheels are rotating. This is called angular or speed velocity. The Greek letter omega, which looks like a W, is the accepted variable used for the angular speed. This is the rate that brings change to the wheel's central angle theta over time. So angular velocity formula says that omega is equal to theta over time, which we could also switch around and say then theta is equal to omega times time. So example 5 says if a central angle spins 15 pi radians in 8 seconds, How fast is the angle spinning per second? Give your answer to the nearest thousandths. All right, so it gave us our central angle. It told us the central angle spins 15 pi radians. Now, what are we after? How fast? How fast we're going, that is omega. So if we're after omega, we're going to use the fact that omega is equal to theta over time. Let's see, we know that omega then is 15 pi. And our time, it says in 8 seconds. So our time is 8. So omega is equal to 15 pi over 8, which is approximately 5.8904. Now it's said to the nearest thousandths, which is 3 decimal places. So we're going to do 5.890, and its units. Now the angle, remember, it didn't have a label, but the angle is in radians, and the time is in seconds. So omega is going to be labeled radians per second. All right, so units and converting between linear and angular velocity. So it says linear velocity is dimensions of lengths per unit of time. So it's going to be like feet per second, miles per hour. It's going to be a distance per time, okay? Angular velocity has dimensions of angle measures or radians per unit of time. So it's going to be revolutions per minute, radians per second, degrees per hour. It's going to be an angle measurement per time. So now let's convert units of angular velocity. So we want to convert 60 revolutions per minute to radians per minute. All right, so we've got 60 revolutions per minute. So I'm going to write that as 60 revolutions per minute. Now I don't need to change the minute, but I do need to change the revolution to radians. Well, so if I want the revolution to disappear, I'm going to put it on bottom. And 1 revolution, remember, is a full time around the circle. And if I want to go to radians, how many radians is that if I go completely around the circle? It's 2 pi. And so we multiply these, and we get that omega then would equal 120 pi. And so it would be radians, because that's what our angle's in, per minute. Now, what if we wanted to take the 60 revolutions per minute and change it to degrees per second? Well, I'm going to do the same idea. So 60 revolutions per 1 minute. Now, I want to convert to seconds. So I'm going to go ahead and work on my time first. So I need that minute to go away. So I'm going to do 1 minute, which remember is 60 seconds. All right. And then I also need to go from revolutions to degrees. So just like we did in the previous one, we know that 1 revolution is a complete thing around the circle. That'd make my revolution cancel. How many degrees is that? 360 degrees. So I'm going to take 60 times 1 times 360 and divide it all by 1 times 60 times 1. So we're going to find that omega is equal to, and it comes out to be 360 degrees per second. All right, then an important relationship between linear and angular speed. It says we can use the previous formulas to find a relationship between linear velocity v and angular velocity omega. So remember that linear velocity tells us that v is equal to s divided by t. But we know that s, remember, is arc length, and that's r times theta. So we start out with, they took s and they replaced it with r times theta. Okay? And so then what they did is they said, okay, we're going to separate this. This is the same as r times theta over t. And what we know from the formula that theta over t is just omega. So we're able to find that velocity is equal to the radius times omega. Alright, so that's what they wrote down here at the bottom. It says linear velocity is equal to V is equal to R times omega. Now, when we're looking at area and distance, the area of a sector, remember a sector is like a piece of it. So think about it like one of those sprinklers that sprinkles just a piece of the lawn. Okay, it's the area that it's covering. So your area is equal to 1/2 R squared theta, and theta is always in radians. It's never in degrees. Almost every time we do a word problem, our theta has to be in radians. Alright, so example 7 says find the area of a sector of a circle of radius 2 feet formed by an angle of 50 degrees. Round your answer to 2 decimal places. Alright, so we're at the area of the sector. So we know we're using the area is equal to 1/2 R squared theta. It says find the area, so we're after A. We know our radius is 2 feet. And our angle, so theta, is 50 degrees. Now, of course, we got to convert that. And so 50 degrees converted is, what's that, 5 pi over 18? So we got A is equal to 1/2 R, which is 2 squared times 5 pi over 18. And so we're just going to type this in our calculator, rounded to 2 decimal places, and we get our area should be approximately 1.75 feet squared. Remember, area is always in squared units. Alright, then to find the distance between 2 cities. Said that Memphis, Tennessee is located at 35 degrees 9 minutes north latitude. And New Orleans, Louisiana is at 29 degrees 57 minutes north latitude. Assuming that the radius of the earth is 3,960 miles and the cities lie along the same longitude, find the distance between the 2 cities. Alright, so this is what we've got going on here. So you got to think about it like on a globe. So here's my equator, and it tells us that the radius of the earth then is 3960. Now it tells us that, I'm going to use New Orleans because it's my smallest angle, okay? So New Orleans is at 29 degrees 57 minutes. So here is New Orleans, and so that would be our angle of the 29 degrees 57 minutes. Then we've also got Memphis. Oops, let me abbreviate. Let me label this. So this was New Orleans. I'm just going to put NO for New Orleans. And then Memphis is a little further north, and it's 35 degrees 9 minutes. All right, and they are lying on the same line of longitude. So they're like on the edge of that arc there, okay, of the globe. So it wants to know the distance between the 2 cities. So I'm looking for this piece right there that I shaded darker. Alright, so the first thing we need to do is we need to find the angle that's between the 2 cities. So angle between 2 cities. Well, in order to do that, I'm just going to subtract them. So I have the 35 degrees 9 minutes minus the 29 degrees 57 minutes. Well, in order to be able to find them, now this is going to give us our angle that we're looking at for our answer, okay? Because this is the angle across from it. So I need to convert them to decimal degrees. So I'm going to take 35 plus 9 over 60, which is 35.15. And then we're going to subtract out, this one is 29 plus 57 over 60, which is 29.95 degrees. And so when I subtract them, I'll find that my theta is going to be equal to 5.2 degrees. Now remember, we're looking for that length of that arc right there, so we're going to need our angle in radians. So I'm going to multiply that by pi over 180. And I'm going to go ahead and just put pi in my calculator this time, okay? because in the end we're going to plug it into our equation anyways. So 5.2 times pi divided by 180, and I found that it's at 0.0907, and I'm going to go ahead and label radians so don't forget that. Alright, so I know my angle, so now I can go ahead and plug in and find my information, because remember, if we're after arc length, I should have wrote this down earlier, that's equal to r times theta. We're after the arc length, we know our radius, it told us the radius was 3960, and now we know that our theta is the 0.0907. And so now we can go ahead and find our arc length. So arc length is equal to the 3960 times the 0.0907. And so our arc length is equal to, I got 359.172, and it's a length, and our length is measured in miles. And so we know that the two cities apart are about 359.172 miles apart.